Hi guys, welcome to another video, and today we're going to be looking at current potential difference graphs. In your exam you may be expected to look at some different current potential graphs and be able to explain what those graphs are showing. Well, let's make a start with our first one. This is a common question that comes up in exams, and it could give you the filament bulb. The filament bulb has the circuit symbol like so, and the current potential graph has this shape where you can see current is on the y-axis and potential difference is on the x-axis. And straight away you guys should be able to see that this graph is not proportional. Current and potential difference are not proportional with each other at all. The reason that current and potential difference are not proportional in this example is that as the temperature increases for a filament bulb, so does its resistance. Now, let's try and explain that in terms of the atoms or ions and electrons. From our previous video, we learned that electrons are trying to pass their way through this wire, which would typically be the filament in a bulb. Now, as the electrons are trying to pass through this filament, the metal ions will be vibrating. But as the temperature increases, these metal ions will be vibrating more. That will be stopping the passage of these electrons through the filament. If the electrons passing through that filament, if their passage is reduced, then that means it's got a higher resistance. You can see from this potential difference graph here that even if we reverse the potential difference, it has the exact same effect. Let's take a look at a diode. The circuit symbol for a diode is placed here at the top. And you can see on a diode that the current increases in the forward direction. As the current is going in the forward direction, you can see here that the current increases. But in the reverse direction, the current is so small it's negligible. We just ignore it. So that tells us that resistance in the backward direction is high. Light will only be emitted through this diode when the current passes in the forward direction. Well, there are two other circuit symbols that you guys need to know. We have a thermistor, and the thermistor's resistance changes with temperature. You can see here that when the temperature is kept constant, that current and potential difference are proportional. But at higher temperatures, the resistance decreases, allowing more current to flow through the thermistor. If the temperature is decreased, well then the resistance increases, allowing less current to flow through the thermistor. Which is quite similar as well for an LDR, or what we call a light-dependent resistor. The light-dependent resistor has a symbol like so. And you can see here that the brighter the light, the lower the resistance, because more current is flowing through. The dimmer the light, the less current that flows through our LDR, which means it must have a higher resistance. Okay guys, thanks for tuning in. Stay in touch for another video.